Welcome, and thank you for joining us for this session on how mass production can figure out Passive House. Joining us today are Andrew Peel, certifier of Peel Passive House, and Graham Irwin, principal at Essential Habitat Architecture. In keeping with this year's theme, both speakers are exploring how they build better buildings, better communities, and a better world using high-volume rapid construction with superior quality control. Let's take a look at how these professionals work in single and multifamily modular to explore how they're evolving their practices. As questions occur to you, please put them in the chat. We can't wait to answer them live when the session is completed. And with that, I'm going to hand it off to our first speaker today, Andrew Peel. Hi, Andrew.
Well, hi, Sharon. Shannon, thank you very much for kicking us off. So I'm going to be exploring a multifamily project in Ontario, Passive House project naturally, and it's rapid modular construction, and will be a really interesting topic, I think, to explore. I'm Andrew Peel, principal of Peel Passive House Consulting. Just a very brief background on us. Basically, we're a firm dedicated to the Passive House world in a consulting capacity, such as on this King William project. Also building certifier. We do a lot of training, and then we've been also working with manufacturers to evolve their products to serve a growing Passive House market. So a little background on the project. So the client is City Housing Hamilton. So they're basically an organization of the city of Hamilton that provides affordable housing. You can see it's kind of nestled on Lake Ontario, south of Toronto. This project is a 24-unit, deeply affordable housing multifamily project. And you can see it's about almost 13,000 square feet. Design temperature for reference is actually 0 Fahrenheit. The architect's Montgomery Sizem architect, a local Ontario architect. And although I happen to be presenting the project, I must say, in terms of Passive House side of things, I have to give my colleagues, Kelly Fisher and Dave Fraser, from my team, who were the main folks driving integrating Passive House into the project. I get the privilege of presenting this project. This project was part of what's called the Canadian Mortgage and Housing Corporation. It's it's a federal government agency that provides financing, grants, and whatnot, funding to projects, both affordable housing as well as market. And they developed a rapid housing initiative because there's a dire need for housing, particularly affordable housing, across Canada. And they wanted to deploy a larger number of units quickly. And so the team, the team was led, it's a design build project. It was led by the modular manufacturer. They put a team together, including us as Passive House consultants. And so basically they're a conventional modular manufacturer that decided to step into this and see, okay, well, can we deliver Passive House? Because that was one of the requirements that they put forward, basically. And the idea is, working with a modular manufacturer, is that we could meet that rapid housing part of the program. Right. For those who are interested, I've included a link to the program if you want to find out more. I'm not going to spend much time on the program itself, but the link is there for reference. Okay, so just a bit of background on the design. It's a 3-story building. It's got a crawl space underneath, and you can see the outline of the thermal envelope, which includes the crawl space. And this happens to be ideally oriented north-south, just how the site was, the available site was laid out. So you can see the south facade there, and then east facade there as well with limited windows. Right. There are some non-straight sections of the building, as you can see. For instance, a bump out for the elevator. Also, the module with the entrances to the building, it's a bit shorter, but essentially everything's kept rectangular because it's modular, right? It's done in 3D, so we need to keep to a certain set of dimensions for the modules. And I mentioned the crawl spaces within the thermal envelope, and this was mainly so that we could run pipes and ducts that would be accessible for installation and any future work if needed. Okay, in terms of the layout of the modules, there are 21 modules in total, 7 per floor. And the way the floor layout works, we actually have 2 suites per module, and that is split by interior corridor here. So you can see studio up here. This happens to be the ground floor with some amenity space. So there actually aren't dual suites within a module, but you could envision the studio module here flipped on the other side. They're all studio. You can see they're quite compact. Again, this is deeply affordable housing. So looking at rehousing homeless folks, people who are precariously housed. So it's a certain market segment that this type of project's actually serving. The module widths vary from 10 to 14 feet. So fairly narrow, as you can see. From a shipping perspective, the modular manufacturer has indicated 12 feet is ideal, and they try to create their as many of the modules as possible as 12 feet. In this case, based on the design requirements, the service needs of the building, we ended up with a 13-foot wide module for the suites. And then 14 foot for the space with the stairs, elevators, mechanical rooms, and then the entrance one is the one with the entrances is the narrowest one at 10 feet. We as best we could, we wanted to stick with as many of the materials and processes that the modular manufacturer was familiar with. Right, they already have their processes, and being a factory setting, they have certain QA/QC processes already. So we wanted to stick with those and just try to embed Passive House into them. Installation materials they're already used to working with, especially the folks on the floor, right, doing the work, membranes, and also the division of labor between what gets done in the factory versus what gets done on site. Not everything can be done in the factory. Even with modular, and we'll see to what extent what was done actually in the factory. But there is a kind of balance between factory and site work. Now, because these are modules and they're going to be transported, they actually have certain structural requirements. There's actually a separate CSA. Anyone who's familiar with the Canadian Standards Organization, there's actually a separate CSA standard for homes that are basically allowed to be transported as a home or part of a home. And so we actually double up our ceiling and our floor. So there's a ceiling and a floor per module, which obviously increases height, but also adds extra timber. But if you think of something with greater structural capacity like mass timber, the amount of timber is certainly a lot less than using mass timber. However, this extra timber does add extra cost to the modules. And then the crawl space, it's not modular, it's completely built on site. The modulars are actually, although they're very narrow, they are flexible in terms of how you create space. And so you can actually create one larger space or room across multiple modules, right? So you can see here on the ground floor, there's a community space that actually spans 3 modules, right? So they design it in a way that they can have openings in the side walls of each module, right? They just have to add suitable structural reinforcement to make sure they can transport that. Okay, but there is some flexibility, so you're not stuck completely with narrow studio apartments. Now, in terms of our planning, there's a kind of another layer of planning compared to maybe a conventional Passive House project, because we have the modularity, like the factory side of things. And the on-site stuff. So there's, coordination of, well, how do we ensure there's a smooth transition between the factory and the site, right? And certainly there's I'd say probably more challenges than a panelized solution, right? Where you're doing panelized walls or roofs. There's just an extra level of coordination, I'd say. And so one of the things we did in planning, everyone knows the red line for your air barrier, indicating where that is. We go further with, variety of different layers to coordinate those, but also distinguish what's done in plant versus on site. So we know that the folks in the factory on the floor, they know they can look at this and say, okay, these are the things that's our responsibility that need to be done on site, in the factory. And then it's clear, okay, what's going to be completed on site. So one of the biggest challenges with modular is the panel to panel. I say panel to panel. I should say module to module connection, the more accurate term. So basically, you've got these modules coming together horizontally and vertically. How are you going to tie those in? I mean, we're trying to do as much in the factory as possible, but we need to ensure that we get a good air seal, weather seal between each module. And so we had to think through this, conceptually as well as practically, both in how they work in the factory and then what gets done on site. Because actually the manufacturer, they can do full modules completed with cladding, right? Delivered to site, which obviously if it's all clad, there's no opportunity to get in there and finalize ceilings for air barrier, right? And so, went to back and forth and discussion throughout the team, the whole project team. We landed on a solution where we would actually leave a section of, so for instance, area between two modules, where we have the insulation clear, and we have it accessible so that we can tie in the WRB and air barrier are one and the same material in this project, and so we're able to access that, seal it on site, and then come and finish the installation. And then also in this case, the cladding was not done. It was decided what would be best is the cladding would be done completely on site. So this is an example of, vertical modules stacked together with the indication of what's left, what would be left to be done on site. And then we also have the roof mate lines as well. And so you can see a kind of a membrane that will come on top of that to seal up the roof after the modules are installed. In terms of the building envelope solutions, this is the exterior wall. And we delineate what was done in the factory versus on site. So from inside to outside, we've got drywall, interior vapor control layer. Then we have our structural layer, 2x6 timber stud. We use fiberglass bat insulation. Essentially, that's what the manufacturers used to using. So they didn't want to change insulation. We used a self-adhered water WRB and air barrier on the outside of that. So I did forget the sheathing layer in this. So there is naturally a sheathing layer there as well that the self-adhered WRB is applied to. And then we actually have an 8-inch prefabricated EPS panel, exterior panel that actually goes on top of that. It's actually a PHI certified product. I've got a list of the various products we used on the project for those who are interested in a later slide. But we actually worked with this manufacturer to help them to certify their project or their product, and we've used it before, but not in a modular capacity. So there was an interesting application. You can see it's probably the cladding solution I've seen with the lowest amount of thermal bridging. It's got an integrated steel track embedded in the EPS layer. And it's actually got, this track is screwed to the wall, and then the cladding is attached to the steel track through a separate screw. So we don't actually have a continuous penetration of metal or a fastener through the insulation. And then the strapping's also applied and actually, sorry, I've got a couple views here. So this is the panel with the track revealed. You can see it will be screwed in, and then you can see they come in and fill this gap in to create that continuous insulation. And then this would be strapped, and that's also done in the factory. And then on site, they finish it with the siding. And then overall, our values 47 for the wall. Okay, we look at a couple other components. We've got the roofs. So the main section of roof, basically the structural part, ceiling joists, they're 8-inch joists. Those are filled with fiberglass bats, again, what the manufacturer's used to. And then we have 2 sections of roof. Mostly it's a truss roof, and that's got 8 inches of blown cellulose ceiling level on site. It's a ventilated roof or vented roof. So, that's our 65. And then there's a section of flat roof that houses some mechanical, like the condensing units. And that has an additional 9 inches of XPS for an R64. Crawl space wall. This was actually originally spec'd as EPS, and then the manufacturer decided to change that to the 6-inch of XPS for an R25 wall. And then the crawl space floor is 6 inches of EPS for an R26. Thermal bridging. I mentioned that the exterior wall system. So I've got the thermal bridging factor. I mean, it's almost near thermal bridge free. The lowest, again, out of any cladding attachment system we've come across. And yet, despite using a passive certified system and modular construction, where we think, okay, we'll have some repeatable details. I mean, there was quite a bit of analysis and modeling that we needed to do, which was say maybe unplanned for. We figured we're using known systems, but just with the detailing we needed to work, and it's the first time we've applied it in a modular setting. It was definitely surprising. 28 models in total. And part of this was to optimize to meet our space heating demand. This project is going for passive certification. So I think there's definitely an opportunity here, for some. We certainly learned some lessons through this project, and we could repeat some details. But the question, and this has been a question in my mind for quite a few years now, like how many projects are repeating this process of detailing? And there's not a great mechanism yet for sharing of details across the industry to really cut a lot of this work out. And then just some things that come up with with the modularity and the structural requirements. We say, okay, well, we plan out, we detail, we do thermal modeling, look at our installation detailing, and then lo and behold, okay, now they need to add some extra timbers for a structure. Obviously wasn't full coordination there. So okay, we got to adjust our framing factor in PHPP to account for it. Luckily, with a big thick layer of exterior insulation, this doesn't have a big impact on our performance. And also coordination with services. So, do a thorough review of service penetrations. Again, lots being done in the factory, but there's this, site to, a bunch of site work, right? And understanding what needs to be done. And what's important for air tightness, for instance. So we have an example here of a duct, sanitary duct going under the insulation in our slab, and we don't have to. There's no interaction with the air barrier, so making sure team's clear. Okay, well, this isn't something we have to worry about the air barrier with. Whereas we have this electrical conduit coming up through the floor, and hey, this is actually right now planned really close to the wall. When you're on site, are you really going to be able to actually get a seal continuously around that, right? And so, okay, well, let's go back and revise some details, right? So these penetrations are definitely important. And this isn't necessarily very specific to modular. It's kind of reinforcing a message here, but it's easy, as we'll see, because there's actually different teams working in the factory versus on site. So these things can easily be missed. In terms of our M&E strategy, it's a central ERV located in a mechanical room on the ground floor, and there's in-suite hydronic fan coil units. So each suite has a fan coil unit. The distribution is, we've got horizontal distribution on the first floor for the supply air, and then on the third floor for the return or extract air. And then we have a vertical distribution through the stack. So there's each stack of 3 suites has a vertical shaft that feeds each suite. And then we have a VAV damper per stack to have some level of controllability of the ventilation rates in each suite. And then with the fan coil units, generally what we try to do is duct our ventilation air separately from the fan coil. So the ventilation air just comes into the suite continuously, no interaction with the fan coil unit. The engineer, basically wouldn't accept that as a solution. So they duct it into the return air of the fan coil unit. This is a very common practice. The challenge there, as we know, the loads aren't very great in Passive House. We're not running the fan coil unit all that often, but we need to run the fan in order to deliver the ventilation air into the suite. So what we end up with is a bit of a parasitic energy load where we have to run that fan coil unit 24 hours per day, but maybe half the time, who knows exactly how much, but quite a bit of the hours of the year, we wouldn't actually need to run it, but we do in order to deliver ventilation air. So definitely a suboptimal solution there. In terms of the component breakdown, I won't spend a lot of time on it. Numerous of you out there will be familiar with some of these products for sure. But it's all electric, right? With a chiller, we've got CO2 heat pump. The odd thing, and this is another engineer-driven thing, we would have used a air-to-water heat pump to provide heating and cooling through the heat pump. But the engineer didn't want to do that. They just wanted to have a chiller. So we have electric heaters inside of the fan coil unit. So it's a bit backwards in my mind. I've got electric resistance heat. So yeah, another suboptimal point, but not something we could move the engineer away from, unfortunately. Yeah, and then in terms of, I just wanted to point this out with our energy modeling approach, we've been evolving this over years to try and streamline the process. And so we've actually developed a pretty streamlined approach. There's, still more optimization that could definitely be done, but we have a neat method to bring in a model from Revit, so a 3D CAD export that we can then bring into SketchUp, build a design pH model around, export that to PHPP. And this is great for workflow for us internally, but also for certification as a nice way of documenting the project. It's a clear connection between basically the architectural model and the PHPP. And actually, my colleague Kelly, who I mentioned earlier, she will have already presented at the conference in an earlier session entitled "Making a Better Crystal Ball." So, if you have an opportunity, if you watch that, great. If you have an opportunity later to watch that, I'd definitely recommend that. She gives a bit more details of this process. And then what we can do is actually take if there are updates to the CAD model or Revit model, we can import that into SketchUp, and then we can identify where the changes are, make the updates to design pH, export that into PHPP instead of, trying to figure out what's changed, which architects may tell you, but they may not tell you everything. And the key thing, like on many projects, to ensure the team is understanding of Passive House requirements and processes. So during the design phase, we did provide virtual Passive House training for novice design team members who hadn't had any Passive House experience, including on the modular production side, so like production manager, so they can understand Passive House, and then also help it, feedback as part of the design team. Okay, this is how we do it in the factory. How's that going to influence our design? We also provided in-factory Passive House training, basically a day-long training for key shop personnel prior to the work in the factory beginning. And then one thing that was amiss on the project, and this is basically down to how it's kind of set up for construction, the modular manufacturer is the let's say the prime on the project, right? They're leading everything. They hired the architect, all the consultants, but they also contract the site work to a GC. So there's a kind of a separate constructor, and they had no passive house training, and this certainly has caused some issues. So that was a kind of gap in the team's knowledge, if you will, and that was just an oversight on all of our part to not really include them in passive house training. So in the factory, just some shots, some highlights from this. So again, their conventional approach of using fiberglass between the studs. So that was no change for them. So no real. Obviously, we want to make sure they're fully filled and stuff, right? But nothing special there. Here's just a look at two sides of different modules, but just to give you a bit of sense. So you can see here the Suprema product here, that represents the exterior wall. So that's our WRB. And then this is a demising wall between suites, which is also wrapped, which is interesting. You think, well, why you're wrapping it? Well, one, they actually compartmentalize every suite. So that provides compartmentalization. And they also use that for protection, temporary protection, as they're moving modules onto the building site. And then what we have here, our strategy to make the mate lines between modules work, is we have some overlap of membranes. So we try to ensure, certain sections where maybe it's a bit questionable, and we have to go back and address that. But we have enough extra membrane along all edges that we can then overlap those modules, both horizontally and vertically on site. Okay, and you can see here on the exterior wall, just typical WRB wrapped. Okay. Window detailing. There's some. This came down to some miscommunication in terms of order of operations. So, and what are the requirements? So, we have our sill flashing here, which happened to be applied all the way around the window. Waterproofing flashing, and then whereas that was intended just for the sill, and then order of operations, they actually put the window flashing on first and then overlaid the WRB over top of that. So again, there's a bit of a misunderstanding on the purposes of the membranes. In terms of a bit of detailing, the window is actually sits slightly cantilevered or proud of the stud wall to get it a bit into the insulation layer, the exterior insulation layer. I can see your detail of WRB wrapping at the window head. The windows were also installed in the factory, and actually we after they'd done the first mock-up, we had a third party come in and do a seal around the window and test it, and actually it passed with flying colors. Might be difficult to see in the picture here. They're using a spoke pencil, just seeing that the smoke's basically floating around, not being sucked in or blown away from the window. So that was our one window mock-up. They weren't going to be testing every window, so obviously the manufacturer's QA/QC processes are critical to ensure that all these windows are going to be replicated as such. And the factory build can go quite quickly, so you're not necessarily getting a third party or other project team member in to check the consistency of all the windows. So the kind of manufacturer's processes are quite critical to this. And then just some other kind of miscellaneous details. A lot of the mechanicals were installed in the factory. So you can see here a lot of the piping, duct work, right? Just wanted to highlight this because this is often missed on passive house projects. We have pipe with a thermal bridge-free hanger, right? So we've got insulation there, the hanger separate, so they can continue the insulation all across the pipe, which is wonderful to see. And here's an example of a VAV box installed in the factory. And even the interior finishes and the stairwells and stairs are actually installed in the factory. right? So the idea is to basically minimize as much as possible the site work. Okay, and then just a little insight in terms of the actual process or work in the factory. The modules are put on wheeled, not lifts per se, but wheeled elements, so they can move through the factory. They got a whole process. I think they have 4 lines in the factory. So I think 4 modules can be worked on at the same time. On the event of stations where they can lift up the modules. So they this is actually great for the workers. So plumbers, electricians, instead of bearing down the whole time, they're actually able to work, from below. And they found that actually, from a kind of worker, like health and safety, I guess, if you will, or like a kind of longevity of work, that works well for them. And then some insight on the on-site side of things. So one of the things that was, one of the things that get missed during design, we had where the sewer invert was, and we had a long sanitary pipe running the length of the building. We ended up realizing, this is going to kind of penetrate into the insulation layer, right, and going to be awkward to lay out. And so we just had to make sure that we actually add extra insulation below the pipe, because this is higher than planned. Or actually I think the other end was lower than planned. So we just needed to make sure that we're getting insulation underneath all of that pipe, and we're not getting any major breaks in the insulation all along this pipe. And then, here's the crawl space being constructed. We do have some thermal bridging, both point thermal bridges with these columns as well as supporting structural walls, right? So, and the engineer didn't want to put any insulation underneath the footings. I'm not sure exactly why that was, if that was soil conditions or something else. So, it's just something we had to deal with in the energy model. And then the crawl space floor was actually insulated after the modules were installed. All right, and then here's just an overview. They did have a little time-lapse camera on an adjacent building, from start, once they were ready to bring, so you can see, I guess this, so the label is hiding it, but we got the first module coming in here, ready to be trained on site. Day 1 of our module installation. You can see what they've done by the end of day 1 through day 4, and then by day 2, and then by day 4 they had all the modules installed, as well as you can see laid out some of the roof trusses there. Okay, one of the interesting things that came up during factory production was we have EPS on the outside. They shrink wrap every module before shipping, so that protects them from weather, and they keep them shrink wrapped until they're ready to bring them onto the building. But they couldn't shrink wrap exposed EPS. It would melt. So what they had to do is temporarily cover the EPS with some OSB to be able to shrink wrap it. And then that OSB is removed, and I've got some photos showing that. That's removed later on when they're ready to apply the cladding. And then, they also have some membrane on the roof for protection. So this could be like an EPDM membrane, so that if a module is left exposed and it rains, that it's protected as well. Right. And then here's an example of our modular seams, right, with not completed. So modules installed, but they obviously need to go back now and, as planned, finish those seams. Right. And just a little note, we didn't have much, just I think at a couple, at the entrances, we did have a thermal break. We've come across a newer product for thermal break that's GFRP reinforced. And a nice thing about this product is it actually, we don't need to cast it in the foundation wall. So we can have the wall built, and then we can drill into that and place this and then kind of install and cast it in, at a later point. So from a sequencing perspective, because we had learned, the foundation wall is done and they hadn't ordered this product. We're like, oh, what's going on? They're like, no, it's okay. We can add it in afterwards. And then the mate lines inside also need to be connected. So all the ductwork, pipework, you can see here the modules that are, you can see the line here, the break, and the pipework, ductwork, not connected yet. All right, and here's an up close shot of that. So they need to obviously go in and finish that inside as well. Okay. ERV installation. This is the room. It's pretty straightforward. They do have a coil. This is another odd thing with the mechanical design. We have cooling in each suite, but they decided to have a cooling coil at the ERV as well. Bit redundant, I think. And then we, making sure that our exterior or cold air ducts do connect with our air barrier as well, right, for continuity of air barrier. And then here, as you can see the difference between the OSB that on some modules where it's still covering the EPS, and then with it removed, right? And this project was meant to be finished a while ago. And unfortunately, as of this date, it's not finished. So this is the latest kind of photo I have of the project. Hopefully by the time this airs, we'll have it completed. So yeah, just sort of some summary notes here, like with coordination. So one of the things is the modular, and we didn't appreciate this, the modular manufacturers had quite a high turnover in the shop. Numerous of the workers aren't highly skilled, and they, let's say tend not to stick around often. So that plus, there wasn't the important passive house information wasn't consistently and universally communicated to the trades folks. So that led to some misunderstanding of requirements, as we saw with, lapping, which order of sequencing for membranes. The modular manufacturer hired a local GC for the modular installation and the finishing. And again, we didn't train them. They didn't have an understanding of passive house. So that proved problematic, because actually one of the things they didn't maybe fully appreciate, even though it was communicated to them, is like that the mate lines need to be sealed right away. Once we've got the modules in place, there's open module there that needs to be sealed. That wasn't done. And so unfortunately we did get some rain penetration into some of the modules. And so they're, they've had to work to dry that out. Right. So he's a clear coordination issue that that's come up, unfortunately. So in terms of lessons learned, I think we, I guess this modular is kind of, there's been some modular passive house, but it's not been a huge area. So, we're still kind of developing details, but we really need to, establish repeatable details that are widely applicable, so we don't get every team reinventing the wheel over and over again. And that includes, getting input from a passive house contractor. The modular constructor knows their thing, but, there's a disconnect there sometimes with the site work. And to some extent we can use existing, details or particularly, passive house certified systems that have thermal bridge modeling done. But those have needed to be evolved. So there's some work to be done here, I think, to, transfer lessons learned, or more than lessons learned, just detailing across the industry. I think this has been missing, and I've been wanting this for a while, and I know others have, and it hasn't happened yet. So this is another kind of call to action of creating a central database of passive details and thermal bridge models. We're basically spending a lot more time in design than we need to, I think. And if we want to scale passive house, even in a modular context, this is clearly important, and it's not being done to a sufficient degree. And then, coordination is just so essential. We know this with passive house, but even more with these multiple parties, multiple builders, right? You got a factory builder and a site builder, and that coordination is critical. And we, this wasn't done adequately on the project, unfortunately. So I'm wondering if there's a better solution where we can get some self-sealing air barrier strategies, WRB strategies, so that modules come together horizontally and vertically, and you don't need to once they come together, they're sealed. We don't need to do extra on-site work so that we limit this exposure risk. I don't have a specific solution for that, so it's another kind of call to action point, but I think it's something that is worth investigating. And then, yeah, really, passive house training for everyone involved. We missed the GC crew, unfortunately, as well as a turnover plan. If we're going to have a high staff turnover or tradesperson turnover, that we need a plan to deal with that, right? And then it's an interesting thing because we've had numerous activities in the prefab space, particularly around prefab panels. And often or at least what I've seen and presented is you're getting somebody new coming into the market and saying, okay, I'm going to create a new passive house panel. And so from scratch, they're basically starting with passive house in mind, and they're designing everything around that. But it's very different to take a conventional prefab manufacturer and upgrade their processes and skills to get to passive house, right? It's just like taking an older tradesperson and they've been doing it for 30 years and changing their methodology and their thinking can be challenging sometimes. So yeah, it's just maybe a bit of a different thought or approach in trying to bring conventional prefab manufacturers into the passive house space. And the first project, even rapid modular construction, it may not go as quickly as planned. This was intended to be completed and occupied a little while ago and still not done. So some challenges there to overcome for sure. And that is me. So thank you for your attention. And Shannon, I'll hand it back to you.
Thank you, Andrew. Great presentation. It was fantastic to see the design build, level of attention to detail, assembly sequencing, on and off site, how the changes in the factory and the field were identified and incorporated back into the model and the PHPP. And I really like that call to action for others to share their details and processes and start with passive house in mind to get as much adoption as we can, as quickly as we can. So with that, we're going to hand it off to our next speaker. Graham, how are you? And what would you like to share with us today?
Thank you, Shannon. Today, I'm going to discuss mass production and of single-family passive house, or particularly production building of passive house. And this is kind of the biggest challenge economically, but also something that has to happen. If we look at statistics for 2020 to 2022, at single-family homes that were constructed in the United States, 81% of them were built by production builders. So the bulk of single-family homes are built by production builders. And if we look at all housing units constructed over the same period of time, we can see that 58% of every housing unit are those single-family production builders. So we'll talk about the economic challenges of this and the opportunities, but this is not something that we can ignore if we're going to get our built environment where it needs to be in terms of sustainability and performance. In terms of economics, the challenge, or a huge challenge with production building, is first cost, because it's a very competitive industry and sale price really drives a lot of it. This is a graphic I borrowed. This was the classic case for passive house. Basically, in a German multifamily dwelling, there's a boiler system for heating. If you build a better envelope, you can eliminate that. And as I understand from colleagues in New York, that actually applies there. Getting rid of the boiler system is a huge benefit financially. Unfortunately, for production builders in much of the US, this is the kind of mechanical system for heating and ventilation that are in these buildings. And a forced air furnace like this is maybe $3,000. And then the ventilation system, if there even is one, is a bath fan running all the time. And we're, at present, our proposition is to replace this with some kind of heat pump and this bath fan with a central ventilation system. And so the first cost argument is a tough one to climb. But beyond just the first cost here, there are other issues that are coming into play that I don't think have been really explored yet, and I'm confident are going to make a huge difference in the future, particularly around the economics of the grid. And as the energy grid goes to be 100% renewable, storage is a huge factor. And people have probably heard about the duck curve, and now there's this talk of the falcon curve. And I don't know how many other birds we're going to bring into the discussion, but it's all around the intermittency of renewable energy, and storage is extremely valuable. So this drawing, I did this napkin sketch at a conference years ago, but it's basically a focus of a lot of my study, the fact that passive houses themselves act as a, if you will, a thermal battery or thermal storage. The shell itself is a storage unit. And as an example, this is a project we did about 10 years ago in Santa Cruz. It has no cooling system because it's in the mild coastal California. But so they use night cooling, right? They open the windows at night to cool off. Every now and again, they get these freak heat waves, and they had a freak heat wave in 2014, and it was over 100 degrees Fahrenheit outside, and the hottest interior temperature was 77 degrees Fahrenheit. So the building is very good at coasting through the day. And again, even if you are in a circumstance where you need mechanical cooling, the fact that the building can maintain its temperature like this allows a lot more flexibility in when that cooling is used. An even more perhaps valuable thing is how an efficient building shell like this can affect seasonal demand. Again, the same house, and we look at the analysis of energy bills, particularly the natural gas, which is the heating source for, there's a solar thermal system on this, but heating source, the backup is a gas boiler. And if you look at this house's seasonal energy use, you can see how relatively flat it is even to what the utility calls efficient homes. And this kind of demand reduction in winter will also be tremendously valuable to the grid, which means that it will become, it will be transmitted to the end user one way or the other. The cost will be borne, we should say. Just some quick stats on how this building compares to typical and how it was before and after. Another challenge we face is the energy models that we use. And it's really important to understand the difference between energy models and what their intended purpose is. Talk about PHPP, or the passive house energy model. Oh, that flipped for some reason. PHPP, or the passive house energy model, is a performance model. It's aimed at delivering a predicted and accurate energy consumption. Things like the HERS index and California Title 24 are also energy models, but they're aimed at compliance. And so their purpose is regulation. And another kind of example I'll use to illustrate the difference between these two, the performance model is more like the bookkeeping for your business. The compliance model is more like your tax return. And so tax return's necessary. It's got all kinds of political and equity issues woven into it, but no one I know would use their tax return as an accurate depiction of how their business is performing. It has an entirely different purpose. This is an example of how that went. This is a case study of a Colorado production home builder who contacted me some years back. They were doing net zero houses. Oh, sorry, this flipped again for some reason. They were doing net zero houses, and their business imperative was to replace or reduce the need for photovoltaics. They were using 10 kilowatts of PV. The subsidies were declining. They thought, well, let's see if we can upgrade the building shell and reduce the need for PV to get to net zero. And their goal was HERS 40 before PV. And they hired me to do passive house consulting on this. And part of my process, I do a lot of very careful optimization and sensitivity analysis on building shells. And the builder had attended a training I was doing and found this appealing. So they contracted me to take their building and see what I could do with it in terms of bringing it up to a passive house standard. And this was kind of where it started. And then this is when it was optimized to passive house. This is showing actually heating and cooling demand combined. I also do that because I want to make sure I'm not driving one up in favor of the other, et cetera. Anyhow, these were the final results. I'm not going to go through all the detail, but you can see that they had a HERS rater also generate a HERS 40 score building in parallel with the passive house. And you can see the heating demand. The HERS 40 home did, maybe 40% reduction from the reference home. I got about a 90%, which is what we expect. We come to expect in passive house, like a 90% reduction in heating demand. But when you look at the relative HERS scores of these two buildings, the passive house got a 34 versus a 40. So much less, much higher performance, much less energy use on heating in Colorado, which is a very heating driven climate, but a very little difference in the HERS score. And went on to try to figure out all this. And I'm not going to go into this in detail, but part of it has to do with the HERS metric. And as I mentioned, the politics of things. So in passive house, in the classic case, source energy is pretty clear, or primary energy is pretty clear, pretty easy to calculate. The HERS, I'm not even going to try to pronounce all of this, the normalized modified end use load, apparently part of the process of developing the HERS score, the natural gas industry was concerned that they'd be disadvantaged by heat pumps. So somehow they came up with this equation, which probably only a lawyer or a lobbyist could love, which is scoring or calculating the energy based on how the actual building compares to the best possible available equipment of gas or electricity separately. So it's all kind of engineered to make sure that gas is not disadvantaged. And as such, it blurs this whole thing. Another issue with scoring kind of improvements, and this holds for any kind of scoring of reduction of energy. So it's the same kind of issue with LEED, Title 24, HERS, et cetera. We have diminishing returns with efficiency improvements. And so, this curve here sort of shows, if you will, the cost versus efficiency improvements. And so for a given cost closer to the reference point, you might get, a large savings like this. The more efficient you get and the further you get from the reference point, say way out here on the right, for the same cost, you're getting a much smaller reduction. And Ken encouraged us for this session to get geeky, so I'll get extra geeky on this, and I'll say that this efficiency versus cost curve is essentially exponential. And so the appropriate way to score reductions would be logarithmic and not linear like this. And I'll leave that for you to ponder. Next case study, looking at California code versus passive house. I was very interested and remain interested in getting wider spread adoption across California that has 16 climate zones. And so I did this study some years ago comparing the performance of a prototype, sort of state prototype, single family home to passive house in all 16 climate zones. And again, I won't go into it, but you can kind of see from these flow charts, the passive house energy modeling system quite a bit simpler than the code system, which I think is based around the desire for production builders to be able to build the same house in any orientation that they want and things like that. So more convoluted and more complicated. In any case, this is kind of what the results look like. On the left here, you can see I basically took the building in code and put it in PHPP and put it in all 16 climate zones. And you can see a wide spread on the left of the heating and cooling demand for essentially, the same building that meets code is a wide spread there. And then going across this chart was stepwise optimized performance improvements. And then on the far right, you can see where we got to with passive house. And there's actually a wider spread there than there would be with passive house, because I just added improvements. I didn't cut back on any of the code measures. I just added to them. We'll see in a minute that another consequence of prescriptive code measures, in some cases, they were more stringent than was required. And that's where you can see that there's a spread on the far right rather than everything hitting the exact same point. This is a look at how the heating and cooling savings across all 16 climate zones. I've got these little green icons are representing the number of passive houses that could be heated or cooled with the same energy demand of a single code-built home in each of those climate zones. And it varies by how extreme, how hot or how cold the climate zones are. This is looking at the optimized building shells. And again, there's a lot of detail here, but what I'm struck by most is how much of this was not an upgrade from code. The most consistent thing across all of them was passive house air tightness and heat recovery ventilation. There's no requirement in the code at all. And secondly, was slab insulation, those kind of traded places. There's no requirement for under slab insulation in the code either. Those two things are pieces that would be extremely helpful in moving the code forward. And if those things are ignored, other aspects are going to continue to be tightened, but they're not low-hanging fruit. So you're going to get more and more diminishing returns with less and less improvement. So the case study to sort of show what is possible. So this was a retrofit we completed a couple of years ago, a single family home in Sunnyvale. We went from 1,200 square feet, 3-bedroom, 1 3/4 bath, to about 1,800 square feet, 3-bedroom, 2.5 bath. You can see the heating and cooling demand on the side for you passive house fanatics. And for other people in IP units, you can see the heating load is 0.4 tons and the cooling load 0.15 tons. So the classic problem we have is finding mechanical equipment small enough to deal with the tiny loads that we have out of these buildings. The clients took about a year before they added their photovoltaics. They wanted to understand how much energy they were using so they could size the system. And then they had some permitting issues with the batteries. So basically the beginning of this year, the beginning of this year is when they first got their photovoltaic system up and running and grid tied. And basically we can see the first 3 months of this year, their utility bills. This is an all-electric home, and they have 2 electric cars that they charge. January through March of 2023, their electric bills averaged $20 a month running their entire house and charging their 2 vehicles. $11 a month of that was the connection fee. In April of 2023, their utility bill was negative $67. So April paid the first 3 months of the year. Because this is basically symmetric around December, I'm predicting that September will pay October, November, December. So it's leaving basically May through August is surplus energy that's being generated for this house from an economic standpoint. And again, a comparison to a typical home and a typical car. And their peak grid draw. So in December, with the minimal, time of maximum energy use and minimal solar, was 688 kilowatt hours. And this was accomplished, you can see an aerial photo here with an 8.5 kilowatt PV system and 2 batteries. And the roof, the south-facing roof was not consumed. And arguably, the solar system's larger than needed to zero the utility bills. At least, I think part of that is because the batteries are helping them harvest the solar more efficiently than if it were just going back to the grid. So all of this comes down to the question, well, passive house economics at scale. Maybe if we can replace these two things with some kind of killer app like the Magic Box we've been looking for, that is heating, cooling, domestic hot water, and ventilation all in one, and of a size that's small enough that the building shell actually enables this savings. And then maybe we can save a whole bunch of PV panels and a whole bunch of batteries. Maybe that flips that first cost equation around. And beyond that, I talked about production building being very challenging, but there might be an opportunity in terms of producing single-family homes at scale where the marginal cost savings of this is actually more compelling than single homes one at a time, custom. So we'll leave that question to be answered, but I think there's a lot of potential. Beyond that is building demand for these homes, for high performance passive homes. And that's part of, we focus mainly on custom high performance homes, passive homes, but we've also been doing some work in what I call pocket production passive house, or pre-designed passive house designs. They could certainly be built in a production fashion, but they can also be built on a one-off thing for people that want a pre-designed building, don't necessarily want to go through the process of design or the expense of a custom design. So this is one that we call the Mendocino. We developed for there was a neighborhood in Northern California that was destroyed by a wildfire. And it's basically 2,300 square feet, 4-bedroom, 3.5 bath. On the ground floor, it's got a flex space, which can function as an apartment or a guest suite or an accessible primary suite or a den or a guest room, whatever. So trying to make these homes visually compelling and very value oriented in terms of efficiency of space and flexibility for people and high quality of living. Another one of those, this one we call the Healdsburg. This one's a bit larger, similar kind of program. We played around with the concept on this one of the geometric perfection of the square. And we put the stairs between the first and second floors exactly centered in the plan. And what that allows us to do, kind of, you can see on the bottom on the left, you can mirror the upper and lower floors independently of one another. So one design has 4 configurations, which maximizes its site responsiveness for people reusing it in different circumstances where the view might be, etc. And that's basically the end of my presentation. Thank you for your time, and I'm open to questions.
Thank you, Graham, and thank you, Andrew. Fantastic presentation, Graham. I love the way you came at a completely different side of this from Andrew and really gave a lot of options for approaching this prefabrication and mass adoption and scaling up from another perspective. So thank you.
Thank you.
Thank you. Greetings, friends, and thank you, Graham and Andrew, for the amazing presentations analyzing mass production from both the project and projection perspective. We're going to kick off the panel discussion portion of the session with the questions that we've been collecting in the chat. The first one is for Andrew. Andrew, what percentage of work happens during production versus on site? Can you speak to that?
Sure. Don't know if I know the exact percentage, but essentially, all the modules, I think there were 27 on the project. They are finished inside. If we go inside outside, so they're completely finished on the inside, including the cabinetry and whatnot. And then if you go all the way to the outside, we have our air barrier on there. And then what they do is they apply the cladding on site. Now, the manufacturer can actually apply the cladding as well, but we wanted to have access to the air barrier on site to finish that, right? I think, as I mentioned, if we're able to get details such that the modules come together and we don't actually need to do any on-site work, then arguably we could get the cladding done on site and have like a basically fully completed module, which I think would be an amazing thing. That obviously needs to be tested in practice on some, I don't know, mock-up modules, I guess, to see how workable that is.
Thank you so much. The next question came from Caleb Crawford, who wants to know about the exterior insulation and cladding applied on site and any issues with the blower door test and what stage that was done.
So the exterior insulation was actually applied in the factory. It's I guess it's kind of a prefabricated element in a way. It's EPS panels, but they're proprietary to a company called Leglet. They actually have a steel track embedded in them. And so essentially what you do is you apply the insulation panel to the wall. The steel track's embedded maybe halfway or so into it. You screw the steel track into the onto the wall, and then you can slide. There's like kind of EPS filling piece that you slide over the steel panel, and then you can attach your cladding to that. So you basically have that embedded. The nice thing about that is you don't have continuous screws all the way through the insulation. They're actually staggered. So actually, in terms of thermal bridging, it's probably the best approach to exterior insulation application that we've seen. And then was there a second part to the question? I've already forgotten.
It was issues with the blower door test and what stage was it done?
Well, we've still been sorting out the panel connection issues, so we don't actually have a full whole building airtightness test yet.
Right.
Unfortunately, so I thought by now we would, but unfortunately not.
To be determined.
Yeah.
And Maureen Sanchez, what the window airtightness testing, qualitative or quantitative?
It was both actually, and the qualitative indicated based on the surface area that we could meet the passive house overall building target. all the necessary caveats added to that, but yeah, I don't remember the specific number, but it did. The mock-up did pass.
Perfect, thank you. She wanted to know what flying colors meant, but I think you've just clarified that. Justin Robert Millet Rodriguez Taylor asks, there is a lot of foam in the project. Would there be a scenario where this manufacturer would be open to less carbon intensive insulation materials?
Potentially, that's maybe for project 2 or 3. The one of the things the manufacturer wanted to do was stick with as many of the materials as they were familiar with and were using already. So that included fiberglass, bad insulation. That's what their standard is. They're already actually using a great membrane, the Suprema membrane. Sorry, I've forgotten exactly the product. But Yeah, so that they're already using that. It's just then improving their detailing, right? Especially around the windows. So this is one of the challenges with working with conventional prefabrication manufacturers is, how do you move them and change the stuff they've been doing for years, right? And very comfortable with. They see risk in changing that. Some simple product swaps, it seems simple to us, but there's maybe factory considerations, various ones that we're not fully aware of that need to be taken into account.
Great comment. And I agree. I think the more pressure we can put on manufacturers to substitute is the most we can do. Caleb Crawford wants to know, why weren't the roofs done as modules?
The which, sorry?
The roofs?
The roofs. That goes back a while now. They're pitched roofs. It's pitched roof, right? So, I think, it's not a rectangle. I'd have to think through about what are the implications there in terms of transport and stuff.
No worries.
Yeah, I don't
We'll
have a
move
ready
on
answer
because
to
I
that,
want to
but
make sure that I give Graham just as much time and then allow you guys to have a bit of a conversation. So Nathan Trick asked, how are the crane straps removed after the first module is set? And is there a special strap chase to allow them to be removed?
I'm sorry, this is a question for me. Okay.
Yes,
I was thinking we're
yes.
moving on to Graham. Okay.
No.
Okay. The details of the craning I'm not familiar with. We weren't as readily involved in that aspect of
If
it.
they designed chases in for strap release or?
That I'm not sure about, unfortunately.
Okay, great. And how did you handle the lift strap areas for the install with the EPS foam CI? Did the OSB cover double as a compression or damage prevention? Do you know if that, a lot of people want to know about strapping.
Yeah, no, these are great questions. Yeah, I'd probably have to get back to you on that one. My
No
apologies
problem.
for having lack of details on the strapping side of things.
No
Wasn't
problem,
something as much
Andrew.
as
It
I
was
was
a
involved with.
fantastic presentation, and it was great that you shared it. Thank you so much. Graham, I'm going to jump into some questions for you. Caleb was wondering, what do the pH reductions mean for the size of PV arrays?
Is that a qualitative or quantitative question?
I wondered the same thing.
Much smaller, right? Like as I explained in that Sunnyvale project, for all his efforts, the homeowner actually grossly oversized his PV array because, at least from an economic standpoint, he's got surplus power from May through August. Like the highest output months of the year are above and beyond his annual or their annual electric bill. So it depends on what the goal is, and that was with an 8.4 kilowatt PV system, which is not huge, right? There was more room on that roof and charging 2 cars. So it's already way oversized for a net zero billing thing. And that's because of the efficiency of the building, and the efficiency of electric cars versus internal combustion cars, but we're not even looking at that as a load on most houses. So yeah, it's immensely helpful.
And Bronwyn Berry made an interesting observation when you were doing the code analysis. She said, still no requirement for smoke tightness in California. Nuts, huh? And I'm wondering if you wanted to comment on that and how you see that playing into the code changes and passive house.
I mean, she's emphasizing the, an ancillary benefit of air tightness, which is a significant one, certainly. But from an energy, if we're just talking about energy standpoint, I mean, the lesson I took from this analysis is that code has already ratcheted down on all of these other things so far that and I'm talking, I do sensitivity analysis on all of these things. So it's like looking at the curve for each building element, and is it, does it have a steep reduction or a shallow reduction? And the shallower the curve gets, the more you need to get even a tiny, it was sort of like that other example I showed of like, get big reductions at the beginning because the curve is steep, and as you get shallower, the same amount of material gives you much less. In any case, the code, as Bronwyn points out, completely ignores air tightness and completely ignores under slab insulation. And so if they desire improvements, which they do, they don't start paying attention to those things. They're cranking the diminishing returns down so far on these other aspects that it's just not, it's economically impractical. It's not sensible.
You need another bird to describe that curve.
Yeah, the cuckoo or dodo bird or something.
The dodo, the cuckoo, exactly. Well, we just have about a minute left. How are both of your practices evolving to face the challenges that you were really digging into during these presentations? What are your practices looking to do next? Andrew, why don't you take it first?
Well, the team did propose a repeat of the project on another site in the same city. That's subject to funding, so it's kind of on hold until the client hears back. But the idea is, hey, can we repeat this, learn the lessons, improve things for the next one? But there should be a lot less design work, much smoother process, quicker to build, all that. So that'd be exciting if they get funding for that. Yeah, a whole bunch of other stuff I could talk to, but you said we only have a
Creating
minute,
that database of details and materials, yes.
Yes, that's on the back
Like
burner
the
at the
call
moment.
to
But
action.
yes, that's definitely something in the forefront, or
Yeah.
it needs to be brought to the forefront.
Thank you, Andrew. Graham?
We're just continuing to do a lot of work on communication and marketing to just get more uptake and more awareness of this, because it's the solution. It's what we need to do. And I just remain baffled at how unaware people are of that, to be quite honest. So a lot of it's just getting better at communicating to people in terms that they understand and care about.
I know you have one person in the chat who agrees with you completely, other than me, and that's Maureen, who just said communication, communication, communication in her last presentation. So it's the new location, communication. Well, thank you, Graham. Thank you, Andrew. Thank you, Passive House Network.
Thank you.
Everybody have a great day. Enjoy the sessions, and we will see you in Denver. Bye-bye, everyone.
Hi, everyone.